Now let's talk about how related rates can be used to determine the behavior of the revenue function. Okay, so this is just one step further. Again, we know that quantity is a function of time, price is a function of time. They're both dynamic quantities that change in time. That makes sense. And we know that revenue is a function of price and quantity as P times Q. Okay, so it depends on what side you're looking at, whether it's supply side or demand side. So that tells you really what Q is. Is Q either demand or supply? But if I want to know how revenue changes with respect to the change in demand and change in price, what I do is take the derivative. Okay? I know revenue is a function of time too, but revenue is a function of time through price and through quantity, okay, or through demand or through supply. Okay? And that means certainly that R is a function of time, but that's because it's P of t times Q of t. Okay? So again, this is a composition of functions. If I want to know how it's changing, I know I can take the derivative of R with respect to time. And what I'm going to do is I'm going to get, really it's a product rule, right? There's a product of two functions, P and Q. Okay? So what I get here is I get, this is dP dt times Q, right? Because it's the derivative of this guy times Q, plus the other way around. It's the product rule, right? So this is P times dQ dt. Okay, again, I don't know what Q and T are in terms of, that is, I don't know what Q and P are in terms of T explicitly, but I can get an idea implicitly when I differentiate. Okay? And so when I do this now, I know a couple of things right away, okay, without doing anything. I know that since if dP dt, right, if price is changing with respect to time, if this is positive, right, so price is increasing, that implies, if I'm talking about demand, so think of Q is demand. Okay. On the demand side, I know that if price is changing in a positive way with respect to time, so it's increasing with respect to time, I know that demand, okay, price goes up, demand goes down. So that means demand is negative. Okay? So if price is going up, demand is going down, and I know that price and quantity are always positive, right? I mean, I can't have a negative quantity and I can't have a negative price. We assume that. Again, P is positive and Q is positive. Then I can get some indication of what R is going to do. In this case, if I'm looking on the demand side, I really don't know unless I explicitly am told what these are. Okay? Because one is going up and one is going down. If these are both positive and this is positive and this is negative, I'm not really sure. It depends on what the rates are. Okay? If demand is changing much faster, decreasing much faster than price, then the rate or the revenue might be going down. Okay? But I need to know that explicitly. Okay? The other thing I can talk about is certainly that other way around. If dP dt is decreasing, so the price is decreasing with respect to time, price is going down, that implies, this little arrow just means it implies, this implies that the change in demand with respect to time, we already know that if price goes down, demand goes up. So this rate should be positive. Okay? And again, assuming that P and Q are both positive, this gives me an idea of how things are kind of working together. They're related. These are related rates. Okay? So this is my general rule of thumb. If, again, prices are increasing, demand should be decreasing. If prices are decreasing, however, demand should be increasing. Okay? So this is how they relate to one another. Okay? And let's go one more step. If I'm looking on the supply side of things, so I think of quantity in terms of supply, okay, then we can actually get some other information out. So let's say Q is now supply. Okay, so we're looking at supply side economics here. So this is supply. So if quantity were supply, okay, what would happen? Well, again, we can actually get some ideas here. Again, if Q is positive and P is positive, I can get some ideas of how revenue is changing. I know that if we're talking about supply, then we have a different kind of relation. If dp dt is positive, so the price is increasing with respect to time, that implies that the change in supply or quantity from the supply side is going to be positive. So they're doing the same thing, right? If price goes up, if I can charge more per item, that means I'm going to supply more items, right? It just makes sense. So this is true, and the other way around, that if the price is changing with respect to time, if this is negative, so price is decreasing, that means supply is going to also be decreasing, right? dq dt would be decreasing, because again, if the price per item that I can charge, right, is decreasing, then I'm not going to make as many items, right? So I'm not going to supply as many things if I can charge less per item if the price is dropping. So on the supply side, the rate of price and quantity is going to be the same sign, right? Not different signs. This actually could be useful to find out what's happening in terms of revenue. That is, that if I know that dp dt is positive and dq dt has to be positive also, if I'm looking as Q in terms of supply side, and again P and Q are both positive, then in fact if dp dt is positive, I know that revenue is positive, right? The revenue is increasing. Okay, so again, using this notion, okay, that using this same idea that if dp dt were positive, okay, on the supply side, if the price is positive, that means the change in supply is going to be positive, right? Supply is going to increase, which implies that since P and Q are both positive quantity, this is increasing and this is increasing, that means that this has to be increasing, right? So what I end up having is this is positive, this is positive, this is positive, and this is positive, right? Bigger than 0, bigger than 0, bigger than 0, and bigger than 0. They're all positive. It means that this has to be positive, right? So that would imply that the rate, the derivative of the revenue with respect to time must also be positive. Okay, so revenue is increasing. And similarly, if the change in price with respect to time is decreasing, that implies, using the same idea, that means that dq dt is negative. So this is negative, this is negative. These are both positive, but the rates are negative. Okay, that means overall, dr dt is going to be negative. Okay, so this means that dr dt is going to be negative. So from the demand side, I can't quite tell you what's happening to revenue unless I have more information. But from the supply side of things, I know that both of these quantities do the same thing. That is, price and quantity are going to be the same sign always in terms of supply. Okay? And that means that if, again, the price is changing with respect to time, if this is positive, okay, if price is increasing, that means revenue has to be increasing on the supply side of things. Okay? And similarly, if price is decreasing, revenue has to be decreasing. Okay? So this is just, again, looking at revenue, price, and quantity, and thinking of these things as functions of time, and just trying to get a general idea of how these relations relate to one another. Again, this is another application of related rates. Okay? Just with revenue thrown into the pile here, and thinking of quantity as both supply and demand.